Okay, in the last class, we have discussed about the dynamics of fluid flow, in which we say that whenever the fluid is flowing, some external force is acting on it. So, if we are going for like if kinematics is also kind of fluid motion only, but we are not considering the forces which are causing the flow. But in dynamics, we are considering the the forces which are causing the flow. Okay. So the next part is the equations of motion, which we have discussed. There are the different forces which are acting on a fluid flow. Those are gravity force, pressure force, viscosity, turbulence, and compressibility. Okay. So this is completely dependent on the Newton's second law of motion, that is Fx equal to m into a. That is x in the direction of x. If the fluid is flowing in direction of x, then F equal to m into a. Force acting in the direction of the fluid. Okay. So this Fx is the summation of all these forces: gravity, pressure, viscosity, turbulence, and compressibility force. Okay. If I go on, if I neglect the compressibility force, then it will be the resulting equation will be a Reynolds equation of motion. If I neglect the turbulent force and compressibility force, then it will be Navier-Stokes equation. And if I neglect the viscous force, if I say that the fluid is ideal, then or non-viscous, then I can neglect this. Then it means that we are considering only gravity force and pressure force for determining the Euler's equation of motion. Okay. So this is the derivation for Euler's equation of motion, in which there is a streamline flow which is flowing through the streamline flow of the fluid flowing in S direction. Okay, and we are considering a cylindrical element surrounding it. Okay, the forces acting on the cylindrical element are: one is pressure 1 at this phase, another pressure is at that opposite direction. Okay, PDA, pressure force it is, not pressure, it is pressure force acting. So pressure force is PDA, on the opposite side it is P plus dou P by dou S into ds into dA. Okay, and another force is what? Weight of the fluid element, that is rho g dA ds. I've told you why it is, because it is rho g is weight into specific weight into volume. Okay, therefore that is complete weight. Okay, then let theta be the angle between the direction of the flow and line of action of the weight element. So this is theta. This is the angle between the direction of flow and the weight of the fluid element. So the resultant force of all this will be PdA minus P plus dou P by dou S into ds into dA, and minus this rho g dA ds cos theta. Okay, rho g dA ds cos theta. So therefore, this is the force which is equal to mass into acceleration. So this is the force which is acting on that fluid element. This is rho g dA ds cos theta. Why cos theta means, if I resolve these two quantities, this will be sin theta and this will be cos theta downward side. So we are considering this to be rho g ds cos theta, because this side we don't want the force, we want the downward force which is acting. So this will be acting at an angle theta. So this force will be rho g dA ds cos theta, which is equal to mass into acceleration. Force is equal to mass into acceleration. How we got this? This mass is nothing but density into volume. So volume is what? Area dA into ds into acceleration. Okay. Next. So as we have said that as is what? Change in velocity with respect to time, dv by dt. Okay. Where v is the function of s and t. Matlab, velocity is the function of space, the distance traveled or displacement traveled divided by time. So I have written dv by dt as like this: dv by dou v by dou s plus dou v by dou t. Okay, dou v by dou s into ds plus dou v by dou t into dt. As v is a function of s and t. If v is a function of s and t, we can write it like this. Okay, so v value is dependent on s and t. Therefore, dou v by dou s into ds, dou v by dou t into dt. Now divide this both by dt. So what will happen? Dou v by dou s by dt, dou v by dou t by dt. So what will happen? Dt and dt will get cancelled. Remaining will be dou v by dou s ds by into ds by dt plus dou v by dou t. Now this ds by dt is what? Velocity. Because as I have told, v is the function of s and t, ds by dt is v. So v dou v by dou s plus dou v by dou t. Okay. Now if I consider it to be a steady flow equation, or if we consider the flow to be steady, then what will be the equation? it will be that like dou v by dou t is equal to 0. So as equal to v dou v by dou s, that will be our final equation. So whatever as is there, it is equal to dv by dt. Okay, this is equal to v dou v by dou s, v dou v by dou s. This is the acceleration, which is the second equation. Okay, the next one is substituting the value of acceleration in equation 1. So whatever equation we have got here, that is this one. I am substituting the value of as. This equation I am substituting in equation 1. So how I got this? So same, I have multiplied with and pda minus p into da, dou p by dou s into ds into da. Okay, so it will be minus pda minus pda minus dou p by dou s ds into da. So this pda and this pda will get cancelled. Therefore, that is shown here. Minus dou p by dou s ds by da minus rho g da ds cos theta rho d da ds dou p by dou s. Actually, here it is v dou v by dou s, v dou v by dou s. So rho ds da is equal to, dividing everything by dividing this whole equation with rho da ds da. So what we will get? This will go, and this will go. So remaining will be dou p by dou s, divide करना ना, तो da ds will go, then rho will remain here, minus g cos theta, da ds will go, rho will go, g cos theta equal to rho da ds will completely go, then it will be v dou v by ds. Then you arrange the equation, and at the end you will be getting like this. So after getting this, we know that cos theta equal to, by seeing this diagram, cos theta equal to dz by ds. So 1 by rho dou p by dou s plus g dz by ds v dou v by dou s, or we can write it as dp by rho. Okay, because the ds is common here, ds is common in the denominator, so we are taking it in common and we are multiplying it with 0, so which will be 0. So dp by rho plus g dz plus v dv equal to 0. This is our equation 3, is the Euler's equation of motion. Okay, now after getting this, we have to go for finding the Bernoulli's equation from the Euler's equation. So Euler's equation is, Bernoulli's equation is the integration of Euler's equation. So the integration of dou p by rho plus g dz integrated. After integrating, you are getting an equation p by rho g plus v squared by 2g plus z. That is your Bernoulli's equation. Okay, any doubts in this? Any doubts? Okay, fine. So Bernoulli's equation from the Euler's equation is p by rho g plus v square by 2g plus z equal to constant, where p by rho g is the pressure head, v square by 2g is the kinetic head, and z is the potential head. So this is the addition of all this is known as total head. Total head is equal to pressure head, kinetic head, and potential head. Okay, so this is the equation for Bernoulli's. Okay, what is the statement of Bernoulli's theorem? It states that the fluid is steady, ideal flow of an incompressible fluid. The total energy at any point of the fluid is constant. So whatever total energy, that is p by rho g plus v square by 2g plus z equal to constant. The total energy consists of pressure energy, kinetic energy, and potential energy. Okay, now what is the assumption made by you? What is the assumption made? The assumption made in the derivations are the flow is ideal, the flow is steady, the flow is incompressible, and flow is irrotation. The questions will be like this. First the question will be like this in the exam if they are asked. State Bernoulli's theorem. Give the assumptions made for the deriving the Bernoulli's equation and derive the equation. So you have to start from the beginning. It doesn't mean that if they have asked Bernoulli's equation, you have to start from here, directly writing the Euler's equation. You have to start from the beginning, from here, then you have to finish here, then you have to state it till here actually. Till here you have to finish, because that equation you have to write here. After writing the equation, you have to explain which is this, which is p by rho, what is p by rho g, what is v square by 2g, and what is z. Okay, then you have to write the statement for Bernoulli's theorem. What is the statement, and you have to write the assumptions made in that derivation. Okay, so this is the way you have to derive. Okay, the next one is, that was the Bernoulli's equation for a ideal fluid. Okay, that was the Bernoulli's equation for an ideal fluid. Now we have to check for a real fluid. What do you mean by real fluid? Anyone? What is the real fluid? So real fluid is one which is having viscosity. Okay, so we have derived the Bernoulli's equation with respect to saying that it is a non-viscous liquid which is flowing. Okay, but therefore it is frictionless. But but in actual scenario, we are going for all the real fluids which are having viscosity. Okay, and which offers resistance to flow. Therefore, there are losses in the fluid flow. Okay, there are losses in the fluid flow. For the real fluid, the Bernoulli's equation is like this. Okay, P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 plus HL. HL is nothing but loss of energy when the fluid is flowing through the any medium. Okay, for an example, I tell you that if this is a pipe through which a fluid is flowing. Okay, at section 1 and section 2, there is two sections, section 1 and section 2. Okay, now if I say that if the fluid is, what will be, see here at this point the velocity will be different, at this point velocity will be different, at this point the pressure will be different, at this point the pressure will be different. Why? Because whenever the fluid is flowing, it is getting some resistance from the pipe and even with the fluid itself. Okay, therefore it reaches, to reach this point it loses some energy. See, like it is like this. If you are walking, you are walking because of friction. Okay, you are walking very perfectly, right? You are walking correctly. Otherwise, you would have slide it down, right? So same way, if there is no friction, there is no movement of the fluid. So there has to be a friction. Otherwise, the fluid will be flowing with a high energy. Okay. So this pipe or whatever medium through which the fluid is flowing, it is offering some resistance to the fluid, and even the fluid itself is offering resistance for the flow. That is called viscosity, which you have studied. So because of that, there will be some loss of energy. So this is the loss of energy between 2 points, point 1 and point 2. So we have to equate this equation and find the loss in the pipe. Okay. So at this point, pressure head will be different, velocity head will be different, datum is same because it is at the same line from the base. If the pipe is like this, for an example, if the pipe is like this, okay, and it is moving upward, it is ascending order. Okay, this is 1, this is section 2. So from the ground it is at 2 meter and from the ground it is at 4 meter. Okay, so this is where Z1 and Z2 will change. Okay, and some pipes will be like this, like a nozzle. Okay, you might have seen a nozzle, right? It will be like this. Okay, so here at this point the velocity will be different, at this point velocity will be low. In the nozzle, the velocity at the exit will be high, but the velocity at entrance will be low. Pressure will be high, pressure will be low at section 2. So because of this changes in energy and changes in this one, that's why we are calling that the loss of energy in the, whenever we use it in a real fluid. Okay, now shall we go for the problems? Okay, so the first problem is, water is flowing through a pipe of 5 centimeter diameter, okay, under a pressure of 29.43 Newton per centimeter square, that is the gauge pressure, and with a mean velocity of 2 meter per second, Find the total head or total energy per unit weight of the water at a cross section. which is 5 meter above the datum line. Okay, so what he is saying, there is a pipe which is of 5 centimeter diameter and under a pressure of 29.43 Newton per centimeter square gauge with a mean velocity of 2 meter per second. Find the total head, that is total head is pressure head, kinetic head and datum head. Okay, of the weight, water and cross section, which is 5 meter above the datum line. So if this is the datum line, the pipe is 5 meter above the datum line. So the distance is 5 meter. This is potential head. Okay, and he is telling that he has the fluid is flowing with some velocity, it is having some pressure, and he has given the diameter. Okay, now, so I want total head. What will be the pressure head? Formula P by rho g. So P is how much? 29.43 into 10 raised to 4 Newton per meter square. As it is was 29.43 Newton per centimeter square, I have converted into 29.43 10 raised to 4 Newton per meter. Sorry for this, it is centimeter square. Okay. 29.43 into 10 raised to 4 Newton per meter square divided by 1000 into 9.81 rho into g. Okay, that is 30 meter. Fine. So next is kinetic head, v square by 2g. V square is how much? What is v square? Velocity. 2 into 2, that is 4 divided by 2 into 9.81 0.204. Now z is already they are given, z is 5 meter datum head. So add all this. Add 30 plus 0.204 and 5 will be getting 35.204 meter. Okay. So here we have determined the total head of the fluid flowing through that pipe of 5 centimeter diameter, which is under the pressure of 29.43 Newton per centimeter square and which is moving with a velocity of 2 meter per second. Okay. So this is the way we have to find out the what? The total head or total energy. Okay. Next. Here. This is a kind of different problem. So the question is like this. A pipe through which water is flowing is having a diameter of 20 centimeter. At this end there is 20 centimeter. At this end there is 10 centimeter. At the cross section 1 and 2 respectively. This is part 1 cross section. This is section 2. Okay. At this cross section the diameter is 20 centimeter. At this cross section it is 10 centimeter. Okay. Now, the velocity of water at section 1 is given as 4 meter per second. So at section 1, the velocity is 4 meter per second. Find the velocity head sections 1 and 2 and also rate of discharge. You have to find out the velocity head. See, velocity is different, velocity head is different. Velocity head is v square by 2g. So you have to find the velocity head at this point, that is v1 square by 2g and here v2 square by 2g. You have to find at this point and at this point. Okay. Now, and you have to also find the rate of discharge. So what is the difference between rate of discharge and rate of volumetric flow rate? Have you studied? Have I told you about? Sir has told you about continuity equation, no? Q. What is Q? Anyone? What is Q? Q is discharge. Q is discharge, or we'll also call as rate of flow. Rate of flow, which is given in the terms of meter cube per second. This is the unit for the discharge. This is the unit for discharge. Okay. Okay. So now, so you have to find the velocity head, that is v1 square by 2g and also v2 square by 2g, and also you have to find discharge q. Okay. Now, so d1 is how much? 20 centimeter diameter here. Then its conversion is 0.2 meter. We are getting the area for this pi by 4 d1 square, that is 0.0314 meter square. v1 is how much? 4 meter per second. 4 meter per second. d2 is 0.1 meter, diameter 2. which is given here 10 centimeter. Okay, then uska area hai 0.00785 meter square. Okay, then what is the velocity head at section 1? v1 square by 2g. So v1 is how much? Velocity is given v1 4 meter per second. 4 into 4 divided by 2 into 9.81, it will be 0.815 meter, right? Now velocity head at section 2. Velocity head at section 2, how much it is? So you have to determine, if you want to determine velocity head at section 2, that is, you should know v2 first. Okay, you should know v2. So to calculate v2, we are using the equation a1 v1 equal to a2 v2. Okay, so what is a1 v1 equation? Which is this equation? Any one of you? Which is that
continuity equation?
Continuity equation. So you have to apply that continuity equation so that you can find out the value of v2. Okay, that answer will be 16 meter per second. Okay, fine. Next, what is the velocity head at section 2? Velocity head at section 2, that is v2 square by 2g. So we have here, see, they have given the velocity at section 1. Okay, how much is the velocity? 4 meter per second. For that, he has told you to find out what the velocity head. Okay, that also be calculated. Okay, here they are telling you to calculate the velocity head at section 2. So for this, what you have to do is you have to find the velocity 2 first. Okay, you have to find the velocity 2. Then only you can determine the velocity head at section 2. Right? Okay, so then only you can find out the velocity head at section 2. So v2 square by 2g equal to, v2 is how much? 16 into 16 divided by 2 into 9.81, that is 83.34 meter per second. Can anyone tell me whether the answers are right or no? Whether the answers are right? At least try to solve this. Don't just keep on saying it. You have to solve them. Okay. So rate of discharge is A1 V1 or A2 V2. So you have to calculate discharge. Discharge formula is A1 V1 or A1 V1 or A2 V2. Okay. This is the rate of discharge you have to calculate. So rate of discharge is 0.0314 into 4 equal to 0.1256 meter cube per second. You can even take A2 V2. There is no problem. You have to take A1 V1 or A2 V2. Can anyone tell me whether if I take A2 V2, whether the discharge will change? For an example, the fluid is flowing through this pipe. Okay. What will happen to the discharge at 1? What will be the difference between the discharge at 1 and 2? Will it change or no? The fluid flowing through the pipe will be remaining same or no? The flow rate will remain same or no? You just calculate and check and let me know. Okay, this answer for this and this. Fine. So this is the way you have to find out the discharge. Okay. Next problem. I want everyone to solve this. The water is flowing through a pipe. There is the water which is flowing through the pipe, having diameters 20 centimeter and 10 centimeter. Having diameter 20 centimeter and 10 centimeter at section 1 and 2 respectively. The rate of flow of pipe through the pipes is 35 liters per second. The rate of flow of pipe through the pipe is 35 liters per second. Okay. The section 1 is 6 meter above the datum line. So this section 1 is 6 meter above the datum line. And section 2 is 4 meter above the datum line. Okay. If the pressure at 1 is 39.24 Newton per centimeter square, find the pressure intensity of pressure at section 2. Find the intensity of pressure at section 2. So what all things are given here? Any one of you? What all things are given? What all things are given? Anyone? What all things are given? What all things are given? You read the question and tell me what all things are given in this. Even I have written the given, at least tell that or at least. Eco हो रहा है. Diameters are given. Diameters at one section and diameters at other section, right? So there is a pipe which is flowing in the descending order. It's a descendant pipe, right? So at one end the diameter is more and the another end the diameter is less. Where the diameter is more, it is 20 centimeter and the diameter less is 10 centimeter. Okay. Now the pressure at this point, pressure at section 1 is 39.24 Newton per centimeter square. Okay. And we are saying that from the datum line, the first section, okay, the first section is at 6 meter above the datum line, and the second section is 4 meter above the datum line. Good. Okay. So as these are above the 4 meter datum line, what will happen? So the fluid is flowing in downward direction, right? So at this point the pressure will be given, and at this point you have to find the pressure. So how are you going to find the pressure? Which formula you're going to use? Any one of you? So I have given the given things here. At section 1, D1 is 20 centimeter. Its area is 0.0314 meter square. Okay. Then the pressure is 39.24, that I have converted into Newton per meter square. Then the Z1 is 6 meter. Okay. Now, sorry. Then what is given at D2 point? 10 centimeter, that is 0.10 meter. The area is 0.00785 meter square. You have to find the area because you have to know the discharge, right, at the end. Okay. Then Z2 is 4 meter. Then P2 is, you have to find out. Now, which formula I am going to use to find out the pressure P2? Can I use P2 by rho g? Can I use P2 by rho g? So we are going to use the Bernoulli's equation. P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. So what happens is, when I use this equation, there are two sections. For section 1, this is the equation. For section 2, this is the equation. Now, I have the pressure P1 39.24 into 10 raised to 4 Newton divided by, I have the water is flowing, so density is 1000 into 9.81 plus. Do I have V1 and V2? Z1 I have, Z2 I have. Do I have V1 and V2? Do I have V1 and V2? How will I find out V1 and V2? Anyone?
Q is equal to A1 into V1, sir.
A1 V1 equal to A2 V2. Why? Because I have to find out the value of this one. Okay. So what I'll do, I'll use Q first to find out the value of A1 V1. Okay. So Q is 0.035 in equal to area A1 is how much? 0.0314 into V1. So when I divide this or do the simplification, I'll get the value of V1. Same using that, I'll calculate the value of V2. Okay, you have to use the discharge equation. So I've done it here. See here, Q equal to A1 V1 equal to A2 V2. So V1 equal to Q by A1, V2 equal to Q by A2. Q is 0.035, same. Here also same. Only what will change? Area will change. Why the area is changing here? Because the diameter is changing. Diameter is 20 centimeter over here and here it is 10 centimeter. Therefore, the area changes. Okay, the area changes. Now, so after getting V1 and V2, substitute the equation in Bernoulli's equation. Substituting the values in Bernoulli's equation, which are at section 1 and 2. Now substitute and get me the answer for the value of P2. Find the value of P2. Get the answer for that. Everyone.
Sir, in calcium we must put all R equals.
Calci you can do this one part first.
No, sir. We must P2 separate and P1 separate, no, sir. Yes, sir. Or we must do at a time also.
You can do at a time all. Otherwise, you can simplify this first, this one. Then you can keep equal to this and multiply everything with this. Simplification, it's easy. You can do it. It's just multiplication and division and addition subtraction. Otherwise, what you do? You keep this as it is. Bring everything like here. This will be minus 4.5 something and minus 4. And do everything and add them. Find P2 value. Then multiply it with this complete whatever value you get. You multiply it with 1000 into 9.81. You get P2. Just find me the answer of P2. Simplify it. It's very easy. Do it fast. How much is the answer?
Sir, 343.85 into 10 to the power 3 Newton per meter square.
No, wrong.
34.38 into 10 raised to 4.
No, wrong. Try. Tell me the answer fast.
Sir, 441.94 into 10 raised to 3.
441, huh?
Sir, 40.27 into 10 raised to 4 Newton per meter square, sir.
Very good. 40.27 into 10 raised to 4 Newton per centimeter square. That is 40.27 Newton per centimeter square.
Square.
Okay. So if you remove 10 raised to 4, it will be Newton per centimeter square. Understood how to solve the problem?
Yes, sir.
Okay. Fine. So the next problem is to be done by you people. Okay. So what is the question is? The water is flowing through a pipe having diameter 300 mm and 200 mm at the upper end. So here it is 300 mm, here it is 200 mm. The intensity of pressure at bottom end is, here at the bottom it is 24.525 Newton per centimeter square, and the pressure at upper end is 9.81 Newton per centimeter square. Determine the difference in datum head. If the rate of flow through the pipe is 40 liter per second. What do you have to determine over here? Determine the difference in datum
Z,
head.
sir.
Z difference, that is Z2 minus
Z1 minus Z2.
Z2 minus Z1, because Z2 is more compared to Z1 na here. See, Z2 is height is more compared to Z1. So you have to find out is Z2 minus Z1. Okay. Now, how you will determine? Everything is given over here. What is given? Diameter is given. Okay. Find out its area for both at section 1 and 2. Pressure is given. Convert that Newton per centimeter square into Newton per meter square for both. Rate of flow is given 40 liters per second, that is 0.04 meter cube per second. To find out. This is the velocity which we have found out. So which equation you are going to use? Which equation we are going to use? Which equation you are going to use? Same equation. V1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. So the same equation you are going to use. Okay. So you have to just determine from this Z1 and Z2. So Z2 minus Z1 you have to determine. You have P1, you have P2, you have V1, you have V2. But the point is that he has not given V1 and V2. You have to find out using the same equation which we have seen previously. V1 equal to Q by A1, V2 equal to Q by A2. Using this equation, you have to do it. So please solve it and let me know the answer of Z2 minus Z1. What is the answer? Z2 minus Z1? Anyone? Any one of you? what is the value of datum head? If you want the values, they are here.
Sir, 14.93.
14.93.
Z2 minus Z1.
Wrong. Try in one full try. You have the value here. Check. What's the answer fast? Substitute the values in P1 by rho g plus V1 square by 2g plus Z1. Okay. Anyone got the answer?
Sir, 13.70 meter.
Very good. 13.70 meter is the difference between datum head. Z2 minus Z1. Okay. We shall see some more problems tomorrow.